Hi, I'm Eric Gould-Bear. I'm an inventor, and I'm a co-founder of an independent R&D lab called MONKEYmedia. It focuses on developing user-friendly technology. My wife and partner Jana Bear is a co-owner of the business, so we're literally a mom-and-pop shop. I've been designing user interfaces for everyday products since the 1980s, and I'm a first-named inventor on over 100 patents and applications internationally. I've held executive leadership positions at some very large organizations, including Microsoft and Yahoo, as well as some early-stage startups like Curb that manufactures energy literacy and energy management systems for smart homes. Teaching best practices is important to me, so I've taught graduate and undergraduate classes at San Francisco State University and the University of Texas at Austin in the Department of Radio, TV, and Film. I'm also a partner in the Capital Factory Accelerator, where I get to provide one-on-one mentoring to up-and-coming entrepreneurs. I have degrees in cognitive science and interactive telecommunications, and I've served as an independent third-party expert on a couple dozen patent matters, opining for both plaintiffs and defendants. To get it out in the open, I'm also a co-inventor with filmmaker and media artist Rachel Strickland on the seamless expansion patents being discussed today. Rachel and I have been collaborating on new forms of interactivity for nearly 25 years. From the seamless expansion approach to interactive video, to our newest technology for eliminating motion sickness in virtual reality and drone piloting. Everything we do involves making technology easier to use and more engaging for human beings. So we invent things, we patent them, and then license them to great companies with means to build and market products that touch the lives of millions of people. The seamless expansion patents have been litigated in the past. They've been challenged at the PTO, and they've been licensed by the largest operating systems and consumer electronics companies in the world, as well as all of the major motion picture studios in the United States. Today's presentation has 3 parts. We're going to talk about the general concept, the motivation behind, and how the basic interaction of seamless expansion works. And we're going to look at the historical context in terms of the science of user experience, some platforms, presentation platforms specifically to understand key terms, and then some related art and paradigms that really set the stage for seamless expansion. Then we'll dive into the patents themselves. We'll look at a storyboard that I sketched back in 1994. We'll look at a prototype from 1996 that ran on the actual hardware it was developed on, and we'll recap with some key terminology. The core question is, how do you maintain a passive cinematic experience while simultaneously offering choice and control? Well, seamless expansion was one result of a 5-year R&D program to address this challenge, and it gives individuals the opportunity to personalize their interactive experiences while preserving the cinematic continuity that sustains audience engagement. It's this form of interactive media that has the ability to insert optional content like audio or video or still images or interactive elements or text right into the flow of a main stream of content. We start with a main audio-video stream, and at a certain point, a user can elect to access optional content, which interrupts that stream, and then it links to an expansion. The main stream is paused, and when the viewer's done, it picks up more or less where the main stream left off. And that's useful in diving into a topic in more detail, for seeing related material, or accessing behind-the-scenes footage. And what's important is that it's all in the context of one main integrated presentation. Now, you might ask, why couldn't you do this with 2 VCRs and tapes and a bunch of old school gear? Well, you could do that. You could put the main content on one tape, on one deck, and supplementary content on another deck. And, watch the main, hit pause, fast forward or rewind to find what you want on the second one, and then when you're done, go back to the first deck and resume playing. You could do that, but seamless expansion really provides a better real-time user experience. And there are some technical aspects that make it different. It puts those functions behind the scenes instead of in the user's hands, and that provides real-time random access. So the seamless integration, that access to the content, is right in the context of the main stream. We get cues that tell a user what's possible, an invitation to expand. We get transitions that ease the passing from the main content to the expansion, or from the expansion back to the main content. And overall, we get an ease of use that's what makes seamless expansion an elegant solution. Next, it's important to understand the established science of user experience because, number one, it's the field of the invention, and number two, there's been a long-standing tension between the perspectives of engineers and user experience professionals. This is often exemplified by differing definitions of a person of ordinary skill in the art and the interpretation of the meaning of patents. So engineers might look at the content on a DVD, for example, and how it's encoded, whereas a user experience professional might look at how does it actually work for people? What's their experience of those pieces? And how would that be occurring from kind of a cognitive science and psychology perspective? The discipline of user experience grew out of ergonomics and what was called MMI, or man-machine interface. So when my grandfather invented the lie detector, he faced the same user experience challenges that we faced in the 1990s, or face today really. How can you make a machine reliably responsive to human expression while being easy to use and unobtrusive? The user interface, it's the boundary or the bridge between a person and a machine, and it includes both the physical and the logical, the hardware and the software, that capture measurable human input and then output processed information for human perception. And there's a variety of acronyms that have been used to describe the field of user experience as it's developed and matured. MMI clearly was not representing the range of genders that we have. Since we use equipment, that evolved into human-machine interaction, or HMI. And now we've got CHI, for computer-human interaction, HFE, human factors engineering, ergonomics, usability engineering, user interface design, or UI. And overall, we use the term user experience, or UX design, to describe the field today, or even back in 1999. So Don Norman, who's considered a founding father of modern user experience, wrote the book The Psychology of Everyday Things in 1988. A few years later, the title was changed to The Design of Everyday Things to meet the evolving terminology. But he taught some key terms that are central to the seamless expansion inventions. And I should mention, Dr. Norman was vice president and the user experience architect at Apple for a number of years, and he's a professor of cognitive science and psychology at the University of California in San Diego. So he taught us some core concepts. The first of those is the term affordance, which lets people know what they can do. In seamless expansion, the notable affordances are the cues to expand, and they're available for a span of time that we refer to as an affordance period. So cues need to be available for a span of time, and that span of time could be the entire presentation, or it could be a subset of it. And that allows users to have a chance to decide whether they want to expand or not during that period. The next central concept that he taught was feedback, and seamless expansion transitions are one of the feedback mechanisms that we use when passing to and from an expansion. It lets people know what's going on, and it eases that passage from one portion of the presentation to another. And the third concept that I'll touch on is multimodality, which is the concept of using various channels of input and output between a machine and a person, like auditory or visual or tactile. The international community of user experience professionals has been meeting and setting standards for 30 years. And so the ISOs are well known in the community around the world, and there's various documents that this community have created through time, and certainly in 1999. And the Association of Computing Machines has a special interest group called CHI that also has been around for over 30 years. There are a number of corporations that have a track record of investing in user experience in the 1990s, including Apple and Sony and Disney and the National Science Foundation. And if you were to get an advanced degree in the 1990s, well, there were a number of places where you could go to get it, including Stanford, MIT, Carnegie Mellon, and NYU, my alma mater. The user experience metrics that apply today were the same in 1999. So when Apple announced iCloud and talked about it seamlessly integrating with your applications, well, let's actually rewind farther. Let's go back to 1999. Darcy DiNucci coined the term Web 2.0, writing about the future of television, wrote that interactive content would be woven seamlessly into programming and commercials. So great user experiences, they're simple, they're easy to use, they're quick and efficient, and seamlessly integrated and effortless for end users. So how do you do it? How do you get these results? Well, there's a science to user experience design, and it's pretty straightforward. We start out by listening to users, and we understand their needs. We invent solutions for them, design them, and then we validate them through usability testing, refine them iteratively, and then we document that in what we call functional specifications. They're like the blueprints for the builders, and those blueprints go off to engineering who actually make the products. So in order to make things simple for end users, there's complexity behind the scenes. And I'm not going to lecture on the science of user experience design, but I want to give you a sense of the world of the person of ordinary skill in the art at the time of these inventions. So there are three well-established phases of design. The first is one we call discovery, and it involves techniques called generative user research, which is figuring out what people need and what they want. After discovery, we move into ideation, and ideation is developing the high-level concepts. We use storyboards. We're going to take a look at a storyboard later so we can see how that phase of design actually plays out. We develop navigational architecture maps, and there's iterative testing in this phase as well. And then we move on to detailed design, and detailed design involves wireframes, interactive prototypes, more usability testing until we're confident that the solution works well. But how do you know with confidence that interactive systems will work as expected? Because after all, human perception is relative and human action is personal. People do different things and see the world in different ways. Well, the well-weathered objective methods of usability testing and usability engineering make interactions with machines predictable, measurable, and reproducible. So I mentioned that Don Norman taught us about multimodality. I'm going to touch on that real briefly because one of the things we know about human perception and cognition is that people benefit when multiple channels are used simultaneously. We're multitasking. We can see and hear and touch and do all of those things well at once. And so when the machine does those things with us, we can be more effective. We can be more efficient. We can understand things better. And in the field of user experience, it's a core competency of user experience designers to be able to leverage visual, auditory, tactile senses, for example, in their everyday work. And there are three general approaches to take, and those are multimodal design, which is using these senses in parallel. There's accessible design, which is knowing when to swap out one sense for another for people with disabilities or impairment. And universal design, which is making solutions work across different size devices and devices in different contexts, so work with big thumbs and small fingers, etc. So it's not just about the visual, but it's about how we engage all the senses. And there's a long history in this field of user experience of working in all these different domains. I find it helpful to look at some multimedia platforms to understand pre-1999 how the inventions of seamless expansion would fit into what the person of ordinary skill in the art would expect at that point in time. So we're just going to touch on a few of them. And the first one we'll look at is HyperCard. HyperCard's an application program, and I put its icons in the top left and right. So we've got the application, which is HyperCard, and then we've got the presentations themselves, which HyperCard calls stacks. And those are the files that it opens. So like Microsoft Word, and then Word documents. And these stacks include both displayable content and executable instructions. The displayable contents like the text fields and the still images and the video and sound. And then the executable instructions are what you might write in HyperCard's programming language, put into menus and buttons, and it also had transition effects. So as you went from one card to another card, you could perform a fade or a wipe and these sorts of things. And both were in the presentation. One of the first technologies that's discussed in the patents is QuickTime. And QuickTime came out in 1991. It came from Apple, and Mike Mills, who is a principal scientist in the advanced technology group at Apple, is considered the founding father of QuickTime. and he had some patents which were cited by MONKEYmedia in the prosecution history. Had some articles as well, and it's worth noting that his degrees are a PhD in cognitive science and a Bachelor of Psychology. He's provided declarations in some of the proceedings relating to the seamless expansion family. QuickTime 3, which came out several years later in 1998, added executable instructions to the presentation file, and these included wired sprites, which were interactive rules for either animations or interactivity, things that people could click, and they're saved right inside the movie file. But it also included video effects. They built in 133 of the standard effects that were defined by SMPTE. SMPTE is a Society of Motion Picture and Television Engineers, basically the people who define the standards for how television works. And these effects included how to get from one portion of video to another, including portions of video that overlapped. So as you do a crossfade, for example, the second segment needs to start before the first segment's ended so that you can do a crossfade from one to the other. And those are all executed. In the developer's guide, it talks about them executing the effect when you run the movie. On DVD, in contrast, transitions are stored content, but in QuickTime presentations, they're algorithmic. And the last thing I'll point out about QuickTime is that QuickTime 3.0, it's when Apple really started promoting audio-only QuickTime movies. And that's pertinent here for a couple of reasons. One is because there's a debate about whether we can have audio-only content. And so in my opinion, a person of ordinary skill in the art would recognize that audio-visual media can include audio on its own, and we'll talk about some more of that later. And going back and thinking, well, what is an audio QuickTime movie? Well, it's the basis of what QuickTime, of what iTunes is today. So all of our digital music has come out of an audio-only QuickTime movie, and that's really where it started getting promoted. Now, when PowerPoint 97 came out, it made a shift from the PowerPoint before, because before 97, presentations were always linear, moving from one slide to the next slide to the next. But 97 incorporated Visual Basic, which not only allowed users to program things, but it changed the underlying functions that they could add into it. And it gave these predefined transitions and effects so you could change how you move from one slide to another in a movie-like cinematic fashion. It gave animation rules so you could determine how different things popped up on the slide just like they were happening in the presentation. And it gave interactive elements so objects within the presentation could be assigned actions so that when a user clicked on them, they could be executed. The last platform I'm going to talk about really isn't a platform, but an approach to integrating content that also was around in 1999. So it's an approach to multimedia that offered the promise of integrating the best of DVD with the best of the internet. So from a DVD, we got fast access to high quality content. And from the internet, we got interactivity and dynamic content. And really, the key innovation here was that we could get portions of the presentation from different places. So you could have a DVD that's enhanced with HTML content, or you could have a website that's enhanced with high quality DVD content. So we looked at HyperCard, QuickTime, PowerPoint, and Web DVD. There were many others that were well known in 1999, including HTML, Flash, Director, some other presentation environments. And they all have something in common, that they're all about presentations and they have a presentation data model. They might just be called different things. HyperCard calls them stacks, QuickTime calls them movies, PowerPoint calls them presentations. And there's a portion of the presentation that's displayable content, and then there's a portion of the presentation that's executable code. And in seamless expansion, we have a main portion of the presentation and the main content. It's a little hard to see here. The video segments and the audio segments and the main instructions are the descriptors of those segments, links, cues, and transitions. And so what the viewer sees are the presentation content, and what gets executed are the instructions. We also get optional portions of the presentation. The expansion has expansion content, and those can be video segments or audio segments like the main presentation content. It can also be still images, text, interactive elements. And expansions also can have instructions, descriptors of those content elements, links to other pieces, or back to the main content, cues, and transitions. So taken together, the main presentation content and the expansion content are the presentation content. So we can talk about presentation content at one time, and we can talk about expansion content. And we'll look at where some of these can come from. Again, the content is what the viewer or the user sees, and the instructions are what executes behind the scenes. So there's another group of instructions that happen behind the scenes, and they're not part of the presentation. And those are instructions that are inside the presentation players. And they can be in hardware or firmware or software, and they're what execute the presentation and the expansion instructions, and they're what actually cause the displaying of the presentation in the expansion content. And those pieces are elements or portions. They can come from many different places, and really in any combination. They can come from a hard drive or an optical drive, or come from RAM. They can come from a network, and if the network happens to be plugged into broadband, then that network can be capable of being the internet, and it can come from there. So in web DVD, for example, we mentioned the main portions of a presentation might be on a disk, and then the optional portions might come from the internet. And there are some claims in the patents that we're going to talk about that split that up in some sort of way. Next, we're going to touch on a few examples that give a sense of the landscape of interactive media that was relevant in the time of the invention and at the time of filing of these patents. We're going to start with one that's referenced by MONKEYmedia in the patents, and it's not even on a computer. It's a book, a choose-your-own-adventure book. And the way these books work is as you read along, you get to a page and you're faced with a choice. And in this case, it says if you make a break for it, turn to page 45. If you decide to stay put, turn to page 100. So it puts some agency and some control in the choice of the reader to decide what's going to happen next. So if we look at this carefully, the book itself has a linear narrative flow, and the story ceases to proceed until a decision is made. And we get discrete decision points. These decision points, really, they stop the story. So we're reading along, we get to a decision point, we have to choose, are we going to turn to page 100, or are we going to turn to page 45? And with these discrete decision points, I should mention, they don't work well in streaming media content because they would stop the flow. They would stop the cinematic experience. But it works just fine in a book. And it works fine in some educational contexts, but not when you're trying to create a flowing cinematic experience. So if we make one choice, we get another portion of content, and maybe we hit the end. And if we didn't like that, we could come back, choose a different portion, and then we stop and we face another decision point, then we may have an end, and so on. And we can explore all these different possibilities. Hypertext has branching that's somewhat similar. It works with fixed content chunks as well, and the content is on the pages that holds links to other pages. And when we traverse those links, it reveals a web of content, just like the adventure books. And there can be dead ends, pages that don't link anywhere. And there can be endless loops, pages that repeat back and forth to each other. Hypertext was cited as prior art in the patents history and in the specifications. And the purpose of that was to distinguish the main content of seamless expansion from hypertext. That the main content needs to be this passively flowing audiovisual experience. Expansions can be many different things, but the main content can't be hypertext because hypertext doesn't flow automatically. Let's take a brief look at how links and hypertext are constructed. Because links, we're going to hear a lot about links in this case, and there's a dispute about whether links need to be fixed and predetermined. So we'll take a look first at a fixed and predetermined link. Here's an example out of an HTML href, and in this case, it's just a link to monkey.com. So every time you follow that link, it'll take you exactly to that page. The link definition can include a cue. In this case, we've got a monkey logo, so people know that that's where they would click on the page in order to follow that link. And it can include other instructions like targeting a blank page which says open up this page not in the window that we're in, but somewhere else in a fresh page. And HTML links, in fact, most links often don't store any information or encode anything about where they're coming from. They're generally unidirectional. And all the links that are talked about in seamless expansion are unidirectional, because all they ever talk about is what content should come next. They point to something else. So seamless expansion not only teaches fixed and predetermined links, but it teaches dynamic links. And dynamic links were well known in 1999 as well. In contrast, instead of having a fixed place to go, they follow rules. And those rules or logic depend on human interaction. So, for example, we can take any checkout process. I've just drawn a prototypical one that we would experience in the late 1990s. And you're checking out, you're buying a product, and then you're faced with a choice. Do I gift wrap this or do I not gift wrap this? And if you choose to gift wrap it, then the button will take us to the gift wrap page. And then from there, you go to the payment method page. But if you don't choose to gift wrap, then the next button will take you directly to the payment method. So behind this button, inside this link, is an if-then rule. If gift wrap, then go to. If we're gift wrapping, then go to the gift wrap page. Else, go to the payment method page. So it's not a very complex rule, and the two target locations are fixed and predetermined. But it itself is a rule that has to be executed that depends on what the user chooses in order to know what to do next. And this was well established in the field of human interaction in 1999. Sometimes programmers don't even know the link targets. Here's an example where the programmer doesn't have any idea ahead of time where it's going to go because the inventory of options itself is not fixed and predetermined. So this is the Google homepage in 1999. Just like today, it had an I'm feeling lucky button. And the way this worked, you put in a search term, and instead of hitting Google search, which took you to a known page, which is a results page that lists all the results, it takes the top search result and just takes you straight there. And so that depends on many things. It depends on what you typed into the box. It depends on what web crawler information is available. It depends on the inventory of advertising that might have reshuffled the order of items in the list. And another example of dynamic link, and the code for this, could be on a server. It could be local. It could be DHTML. It could be JavaScript. There are many ways that it could be done. So we're going to move on to some video examples, and we'll start with Dragon's Lair, because Dragon's Lair was before the patent office as prior art, and it's discussed in the specification. Dragon's Lair was a first-person interactive video game, and the content was stored on Laserdisc. In the arcade, it came out in 1983, and a few years later, it came out on DVD in 97. And then several years ago, it came out on iPhone, and they came out with a Dragon's Lair 2. So in this game, it's kind of like the Choose Your Own Adventure story. The video plays, and at certain points, the user or the player has to make a decision. Are they going to go left? Are they going to go right? Are they going to lift their sword? Or, whatever they choose to do, those choices determine what pieces of video plays next. So like the book, it has a linear narrative flow, and it has some decision points that can occur within very short affordance periods. And there's a segment of video that plays, and then there's an affordance period, and that could be a few seconds at most during that period, and the user has to make their choice very quickly. And if they don't do anything, then the character is going to die an ugly death because they failed to jump at the right time or slice the monster at the right time. But if they do take the action at the right time, then they get another segment of video, and then they get another short affordance period, and if they don't do anything, then they'll die another different awful death, and so on. And it kind of makes its way through that way. And I'd like to show you a brief clip of this to get a feel for the length of these affordance periods in the game. And the cues, they're not very obvious. There's a couple of places where we'll see a cue, something flashes, but there are other times you just need to know what happens. And it's a great way to lose a lot of quarters to learn how this worked.
Dragon's Lair, the fantasy adventure where you become a valiant knight on a quest to rescue the fair princess from the clutches of an evil dragon. You control the actions of a daring adventurer finding his way through the castle of a dark wizard who has enchanted it with treacherous monsters and obstacles. In the mysterious caverns below the castle, your odyssey continues against the awesome forces that oppose your efforts to reach the Dragon's Lair. Lead on, adventurer.
Well, that's enough Dragon's Lair. You get a feel for how this works. So it's this flowing content, and it's different than seamless expansion, where if you do nothing in the main video, it plays out, and you can have a passive experience. But in Dragon's Lair, if you do nothing, you die, and you have to spend more quarters. In 1997, Jim Taylor wrote DVD Demystified, the first edition of DVD Demystified. And it's really one of the go-to references on DVD authoring. You know, I think of Jim Taylor's book and Ralph LaBarge's book really as two of the key books that we look to in authoring to understand how it all works and what might need to be done to make it a creative piece. He talks about DVD branching that involves sequences that are all fixed and predetermined. And one of the things that you can do is you can have different paths through a DVD. And the pieces of the DVD that are all encoded are broken up into these little chunks, and they can be called chapters, and they can be called programs. And really, the only way for a DVD to jump is to the beginning or to the first terminus of one of those segments. And it's critical to understand that that's not what seamless expansion is about. And a developer could make seamless expansion using fixed and predetermined encoded chunks like that, but there's no guarantee that you get the seamless expansion experience. They just don't equate. Another predecessor technique from DVDs was the ability to have multiple camera angles in a single presentation and then let the user switch on the fly between those different angles. So you could shoot a sporting event or a movie or a TV show with 2 or more cameras using different camera angles. They get encoded, interwoven onto the disc so that you can jump at any time. And so, in contrast to DVD branching, it's not relying on pointing to a point in time or a chapter break. It's just saying flip channels, if you will. Basically, flip which angle you're going to be looking at this as this movie is playing out. And those are often talked about as scenes. There are a couple of patents that were before the patent office in the prosecution history, one by Hirayama and one by Nakai, and they talk about scenes. We can also call them chapters. We can call them scenes. And those are distinct from the segments that are experienced in the seamless expansion invention. So we'll get these concepts distinct, and we'll take a look at how this works. So here we have a linear flow, and in this example we've got 2 camera angles and we've got it broken up. We've got 4 scenes, and there's one that was playing when we lead in, and there's another 2 that we can see their wholeness, and the 4th one leads off the screen. So we have an affordance period, could be the entire movie length or a shorter period, and in this case, at any time the viewer can click to jump between these camera angles. So they can decide to jump from camera angle 1 to camera angle 2, and then at a later point jump from camera angle 2 back to camera angle 1. And these decision points, a term that shows up in the patents, are events. There's something that actually happens in time. And the endings of the stored scenes, these dotted red lines, they're not material to the user experience of switching angles. They may be useful for seamless branching, but they don't affect angles. So the termini that you see here are the relevant portions. Those are the relevant beginnings and endings for the discussion. So when the user first clicks to jump from camera angle 1 to camera angle 2, it ends that segment of camera angle 1, and then it begins the segment of camera angle 2. And when they made that choice to jump from camera angle 2 to camera angle 1, it ends the segment and begins the next one. So we can talk here fairly easily about these portions of content and what actually is going on. And I use the term segment in the patent, and I use it here today in the same way that I used it back then to refer to portions or parts of the content. Now, this switching between camera angles still isn't the same as the choice in seamless expansion, because here when the user switched to camera angle 2, they're missing content from camera angle 1 that would have played between those 2 decision points, because it was all flowing simultaneously, the 2 different angles. And in seamless expansion, we don't miss anything from the mainstream. So there's a similarity, but the 2 are quite different inventions. to be clear, in seamless expansion, we make a decision and we come to expansion content. And what was in the first stream is now paused, and we're not missing anything. So when we finish at the end of the expansion, we pick up where we left off with the main content. Whereas on this angle switching, you've actually missed a bunch of content that would have been playing from camera angle 1 while you were on camera angle 2, and you never get to see it. So that not missing content is important. And it's not just important in seamless expansion, but in people's experiences of live TV, for example. So on the DVR, TiVo gave us a way to pause live TV and not miss any content. So for example, you're watching live TV and your stomach starts growling and you want to run to the kitchen and get something to eat. Well, before the DVR, you'd have to wait for an ad and run quickly and come back quickly. But with the DVR, we can hit pause, go to the kitchen, get a snack, and we know we're not missing anything because that live stream is now caching to a hard drive. And we come back, it picks up more or less where we left off. So live streams of audiovisual content on TV can be considered segmented media, continuous play segmented media in one sense because it comes in packets, but in another sense because we can talk about the segment that you watched before you went to the kitchen and then the segment or portion that you watched when you came back. That's the continuing portion of that content. And the patents teach how to take advantage of the hard drive cache and the DVR in order to be able to insert content expansions on the fly. So we'll take a look at a similar model to the DVR, but now instead of going to the kitchen to get a snack, we're going to experience an expansion. So we have a main stream of audiovisual content. Again, it can be made up of packets, and how those are segmented is interesting, but it's not really relevant to the portions that we're talking about for seamless expansion. We have an affordance period, which is when we're given the opportunity to access an expansion, and the user takes action. They click or tap or do something. They've asserted a decision point, which interrupts that stream and ends that portion, effectively delineating the first segment. And now we know when that first segment has ended. And they can experience the expansion, whatever type of content that is, while the live content is now caching to the hard drive. And when they're done, the continuing segment resumes, more or less from where the program was interrupted. So they haven't really missed anything in order to go to the expansion, right? So that's enough about the prior art. In 1994, Rachel Strickland, who's a videographer and architect, she brought me the following challenge. She had shot over 80 hours of footage from around the world about people and the things they carried with them in everyday life. And she had also collected still photographs and illustrations and audio segments and written material. And she wanted to create a documentary video that would have a passive mode, something that could fit into a normal broadcast schedule, and then also have an interactive mode so that somehow people could access the full range of the materials that she had shot and she had collected. And that way, each person could have an individual experience, and it was driven by their own idiosyncratic desires and, what's important to them. So she had come to me because there were no existing presentation paradigms that would meet her needs. So seamless expansion was born out of our attempt to solve this problem. And then we evolved and refined it over the course of 5 years. The prosecution history of the patents includes a set of storyboards that I drew back in 1994. And a storyboard, well, it's just a simple design tool that helps tell a story, and it paints a picture of how something works over time. This one shows affordances. It shows feedback. It shows interactions and how they play out. And I'd like to walk you through the scenario that's illustrated on these pages. So to set it up, we're talking about a consumer experience, and we have a viewer, Dolores in this case. She's sitting on a couch. She's got a TV and some sort of set-top box. Content is on an optical disc, and she's using a trackball in this case as her input device. She sees a semi-sewn together montage of animations made up of video keyframes, and she can drag her input device to nearby places. And when she selects one, she gets a voiceover introduction as a transition. The ... is used in storyboards to show passage of time as a transition to the actual video footage. So here, audio is serving as a transition, not video, and it's simply just the audio. So now the user has experienced the main presentation content and this funny looking picture. I've drawn the TV tube around the outside, and then in the middle, this humpy looking thing is how we draw an abstract picture of a person, and this is something that Yin Wang taught me when I was an intern at Apple. So on screen we have a talking head, and in the prototype we're going to look at, you're going to see people framed like this, and these are what we call video portraits. And they'll be talking about the things they have with them in their pockets and their purses that they carry with them in everyday life. So here we have a cue that's visual. It indicates that the speaker has more detail to tell. And if the user is interested, they can click. So that's the prompt, or the guiding suggestion that the viewer can expand for more detail on that topic. So she elects to expand, and this time the user gets a visual transition effect instead of an audio transition. So that bubble starts to grow, and now the person, the viewer, is experiencing the expansion. And the expansion has substantially filled the frame, and now we're inside the expansion. It happens to be the same person now talking in more detail about something. So some time passes, and they can either wait for the expansion to finish or they can exit prematurely. The patent specification talks about premature contractions as a way that a user can initiate getting out of an expansion when they want to end it early and get back to the main content. So the main content presentation we're back at, and it resumes at or near where it was interrupted. Those original 1994 sketches served as a basis for some of the figures in the patent specifications, and those correspond here to figures 4A through 4D. And what we see here in A is the affordance period with a cue. In B, we get a multi-stage transition effect. In C, we have the expansion filling the same space as the main content. So it's forming a continuity, a spatiotemporal continuity with the main content. And then we see resuming the main content where it left off, and when we're done with the expansion. So from 1994 to 1998, Paul Allen's Interval Research Corporation and MONKEYmedia collaborated in the development of many different prototypes relating to seamless expansion. And today, I'm going to show you one that my co-inventor and I call Baguett. And we're going to look specifically at version 5.0, and there's a run-through of this that was recorded in front of the Patent Office as part of the prosecution history of some of the seamless expansion patents. And that's what I'm going to play for you now. This is a demonstration of one in a series of interactive video prototypes built by MONKEYmedia. This is version 5.0 of the prototype codenamed Baguett. It contains 5 linear video portraits about the ways people organize the things they carry in their bags. The video we'll watch features Phyllis Morrison, author and educator, who famously co-authored The Powers of 10 with her husband, Dr. Philip Morrison. Dr. Morrison, a theoretical physicist and group leader in the Manhattan Project, is one of the other portraits in the prototype and is featured in one of the expansion segments from Phyllis's portrait.
Date book.
During the display of each portrait, links are offered to access optional expansion videos of the portrait. Also present are links to optional video segments from the other portraits, as well as links to supplementary text and still image content. The Baguett prototype series served as R&D tests of what could be accomplished with audio and video presentations received via TV broadcast signal, transmitted across computer networks, or distributed on the optical disc, such as the format we now know as DVD. In this version, the audiovisual test content was stored on CD. I'm fast forwarding a bit right now to save time because it takes a while to get to the first expansion opportunity.
Cards and that sort of stuff is. There are always a lot of things just hanging around the bottom, but this is a nice part of the purse. This is how you can manage to have so much in the purse.
The
and
fuzzy
still be
white
able to
outline you
find
see
things.
here is a visible
Here
cue
are
for
the
audience
tickets
input.
for the airplane
This
on
affordance tells the
Friday.
audience that
And
optional expansion content is available. If we do nothing, the continuing segment of video is
a sky
displayed.
map for the month. I carry that because it's a nice thing to give away. And I made this because I know a magician who always says, have a card, any card, and I wanted to be able to do that.
Here's
It's a
another
puzzle
affordance.
because
Let's
you can
first
hand it
watch
to
what happens if
somebody
we don't do anything.
and say,
This gives you a sense of how the
"Can you
first
figure
segment
out
links to the
something
continuing
about
segment.
this?" And pleases me.
Now, let's rewind and follow the expansion link from the first segment to an expansion or second segment.
I wanted to be able to do that. It's a puzzle because
The program receives audience input and determines that the
say,
expansion was elected by the audience. Notice how the expansion content is inserted directly into the flow of the video. Then, when the expansion is done, the main video is going to resume.
And it's a sculpture made by an artist. And eventually, people do figure out, can we look at our microphone again? That can be a piece of magic for a tired child on a bus or a subway or an airplane. And pleases me.
Now we're seeing the continuing segment of the main video.
We're getting there.
At the next expansion opportunity, I'm going to show you interactions within an expansion. We'll first choose to expand to learn more about Galileo's telescope, and then we'll interact with other portraits. When we're done with the other portraits, we'll come back to the expansion about the telescope.
This telescope is...
I only wear glasses
From inside the expansion segment, we can follow a subsequent expansion link to another video.
that take up a lot of room. So
the main thing that everybody wouldn't have. You'd be surprised what this is for. Of course, it could be for watching birds or going to the sea, and I often use it for that. But it's mainly for going to MIT, because if I go to a lecture, these wretched people are always putting slides and transparencies up that nobody can see. And
telescope. This telescope is...
Now we're back in the expansion about the
copy
telescope.
of Galileo's
Notice how the video
telescope.
appears to have rewound
When
just a bit
Galileo
before
developed
resuming.
the telescope,
In this case, it was less awkward and perceived to be more seamless if we didn't resume the main video in the middle of a sentence. Instead, we're returned to the main video at a point in time just a bit earlier than the point at which we left.
kinds of eyeglasses, and if you put them together in the right way, they make the telescope, and I see things much larger. A, it really works, and B, again, it's something that one can share with people.
Once again, we're seeing the continuing segment of the main video. In contrast to the previous return link, this continuing segment appears to pick up right where it left off. The locations and time to exit from and return to the main video may depend, in part, on the context of the materials used.
There are, papers, various papers, some of which should be thrown away. And then some very useful things. Strong.
Here's a textual expansion. The audience can scroll down through the document or up and move at various speeds.
Very useful things. Strong rubber bands, good for holding a bunch of books
And we've
together.
returned to the main video
Or perhaps
just before
if you
we
have
interrupted it.
something and it has an electric cord attached to it, you can fold up the cord and put the rubber band around everything. Oh, half a cookie.
Here's an example of a still image expansion. Notice how it fully obscures the main video.
Oh, half a cookie. Very good.
And the continuing segment plays
One
until the
piece
video
of
is over.
string. You should always have a piece of string in your purse. No purse is complete without it. And that's about it.
Those are just amazing people. Baguett used both static links and dynamic links, and Figure 7 from the patent illustrates dynamic links. And since this fact is contested by the parties, I'd like to briefly touch on it. Dynamic links are really hard to put into a static image, and it's one that we in the user experience profession spend a lot of time trying to figure out how to illustrate something in a static image that's temporal in nature. The specification text makes it clear by describing it from many different angles. So what we have 214 is an affordance period. It's a period of time in which a viewer can click or make a decision in another way. 216, 218, 220, and 222 are representative potential decision points of what could be, an option to jump out at any frame during that affordance period. And practically speaking, it doesn't really matter how many there are because the computer can take care of that jump within that range. And the actual decision point, it doesn't really make practical sense to be fixed and predetermined because there can be so many of them and because it depends directly on what the person does. There can be hundreds or thousands of millions of frames in any given affordance period. And I just chose to draw 4. And anyone reading the patent would understand that they're representative of such mass multiples. So if we look at the actual encoded video on the Baguett discs, we'd see that Phyllis's portrait is one long video that contains all the presentation content related to her. It has all the main stuff that she talks about, and then it has the expansions, and if you actually played that in a QuickTime player instead of in the Baguett presentation experience, then it would just play through. You'd see the main, and then it would play one expansion, then another, and then another. And that's just how we happen to store it on the disk. And there are also multiple tracks in it, kind of like angle tracks on a DVD. In the middle here is the main track, and the fuzzy white outline is actually baked into the video frames. This is not necessarily the best way of doing it, but it's the way that we were able to do at that time. It's actually in the video throughout the affordance period, and it spans from the first pin in the main track to the second pin in the main track. So here we don't see the white outline before that when she's holding the cards because there's no affordance at that time. That's the cue that lets you know what you can do. And on the top track, what we have is a mirror of the affordance period, but in that track, the cue is actually brighter. Since we were using cues that were in the video as opposed to a sprite or some sort of an overlay, we used track switching to make it look like it was highlighting, and I'll show you how that works. And then on the bottom, what we have is the expansion track that doesn't have any cue in it because, well, it's the content of the expansion and there's no need to show a cue at that point because the user's already in it. So this cue here is showing for about 6 or 7 seconds. It's a short period of time. The viewer elects to expand sometime during that period, and the cue track is going to flash on momentarily and then off, and then the display is going to jump to the expansion track, and then it's going to play. So we saw a bit of the affordance, the cue got brighter, it got darker, and then we're into the expansion. So there's no segmentation on the disk that relates to any of these jumps. It's all algorithmic, and it's totally dynamic. And in a way, you could say it's fixed and predetermined because the algorithm is fixed and predetermined, but we really don't know which termini are going to apply until it takes place, because it depends on when the viewer elects to expand, when they would get the brighter cue, when the expansion itself would start. If they clicked earlier, it would happen earlier. If they clicked later, it would happen later. So what I'd like to do is bring Figure 7a to life for you so that you can see how it actually reflects what's going on in the invention. So we have this affordance period. Well, I should point out a few things we know about Figure 7a and the preferred embodiments from reading the specification. One thing is that a decision point can establish the ending termini of the segment it's in. So it can be in the end of the first segment of the main stream. It can also, a decision point, establish the beginning terminus of the continuing segment. We know that decisions can be as frequent as every frame, and we know that expansion segments can vary for, with every decision point. So the termini of the expansion itself can grow earlier or later temporally. So if the user takes action early on, then it jumps early in the expansion, and the later they click in the affordance period, the later the expansion. So they get a different expansion segment really because a segment is defined by its termini. We actually get a different segment, a different portion, a different part of the video. And there's some common content between these that they'll get in each case, but the segment itself is going to be different. And again, it's an algorithm, it's calculated, and granted that algorithm or that logic is fixed and predetermined, we don't know which part they're going to have watched before and which part they're going to watch after until it actually happens. So putting it all together, you get figure 7a. So in this embodiment, it can't be done with static links. And no matter how you slice it, there are no fixed and predetermined boundaries between the main content and the expansion. It's all done on the fly. Well, let me take that back. You could hard code static links for every single frame, but it just wouldn't be practical, and no person of skill in the art would actually implement it that way. So hopefully I've made clear what's meant by segments in this patent and how one of the many preferred embodiments works, and that with the Baguett example, and particular in figure 7a, how segments, links, and termini can all be dynamically defined. And that's my introduction to seamless expansion. I wish I could be there in person to answer your questions, but I guess you'll have to talk to my lawyers. So thanks for giving this good attention. It means a lot to me to have it understood and construed properly. Thank you.